Yes, I agree that it will take time, but you have to mix them slowly, else you might get burned. Oh yes, I feel the container hot. Why is it so? Let me tell you, it is because of the reaction between acid and bases. Children, in this lesson we will learn about the chemical properties of acids and bases and about salts. Objectives. At the end of this lesson, you will be able to describe the chemical properties of acids and bases, identify the common properties of acids and bases, describe the strength of acids and bases, explain salts. The chemical properties of acids and bases. An acid is a substance that produces hydrogen ions when added to water, whereas a base is a substance that produces hydroxide ions when added to water. Both acids and bases have different chemical properties. Let us look at their properties. Olfactory indicators. Suppose you are given 4 chemicals and asked to identify them as acids or bases. How will you do it? Let us find out. We have olfactory indicators which indicate whether a particular substance is an acid or base due to change in their smell. They are used in the laboratory to test whether a solution is a base or an acid by a process called olfactory titration. An olfactory indicator works on the principle that when an acid or base is added to a substance, then its odor cannot be detected. For example, the juice of the red cabbage. This liquid has a blue-violet color, but when it comes in contact with acidic substances, it becomes red, and when it comes in contact with base substances, it becomes green and even yellow. Did you know? Every liquid you see will probably have either acidic or basic traits. Water, H2O, can be both an acid and a base. It can be considered an acid in some reactions and base in others. Water can even react with itself to form acids and bases. Reactions of acids and bases. Let us go back where Gaurav felt the mixing beaker hot. When acid is mixed with base, it produces heat. This may cause the mixture to splash out. This may cause you burns. Also, the glass container may also break because of excessive local heating. So we must be careful while handling acids and bases. Let us look at the different reactions of acids and bases with metals, metal carbonates, and metal hydrogen carbonates, and with each other. Reaction with metals. All metals above hydrogen in the reactivity series react with dilute acids to form their respective salt and free hydrogen. Active metals such as potassium, sodium and calcium also react similarly but explode when combined with acids. Reaction with metal carbonates and metal hydrogen carbonates. Acids react with carbonates and hydrogen carbonates to form their respective salt, water and carbon dioxide. Reaction with each other. Acids and bases are the chemical opposites of each other. The action of an acid and a base nullifies the effect of one on the other. This is known as neutralization reaction. In this reaction, an acid combines with a base and forms a molecule of water and the respective salt. Reaction of metallic and non-metallic oxides. Now that you have seen how acids and bases react with metals, hydrogen carbonates, and with each other, let us look at how acids react with metallic oxides and bases react with non-metallic oxides. Reaction of metallic oxides with acids. Oxides that add on hydroxyl ions to their molecules are called basic oxides. These oxides get neutralized when they react with acids. Acids undergo neutralization reaction with basic hydroxides to form salt and water. Reaction of non-metallic oxides with bases. The reaction of calcium hydroxide with carbon dioxide produces salt and water. This reaction is similar to the reaction between a base and an acid. This proves that non-metallic oxides are acidic in nature. Did you know? When an acid and a base react with each other, they form water. the acid gives away an H plus ion and the base accepts it by bonding it with the OH ion. This is why an acid is called a proton donor and a base is called a proton acceptor. Reaction with water. When acids are mixed in an aqueous solution, they produce ions. When dissolving an acid or a base in water, you have to remember that it is a highly exothermic process. While adding water to a concentrated acid, keep in mind that the heat generated may cause the mixture to splash out, which leads to burns. This may lead to the glass container breaking due to excessive local heating. When you mix an acid or base with water, it results in decrease in the concentration of ions per unit volume. This process is called dilution and you get diluted acid or base. Strength of acids and bases. You need to use a universal indicator to find the amounts of ions present in a solution or to find out how strong an acid or base is. The universal indicator is a mixture of several indicators. It shows different colors at different concentrations of hydrogen ions in a solution. A pH scale is a scale of measuring hydrogen ion concentration in a solution. You can measure pH from 0, which represents very acidic, to 14, which represents very alkaline. Neutral elements have a pH value of 7. Did you know? The chemical properties of all acids are similar. You know that hydrogen gas is released when acids react with metals. This proves that hydrogen is common to all acids. However, you need to find out if all elements that contain hydrogen have acidic properties. Importance of pH in everyday life. Let us look at some examples from our day-to-day life where pH forms an integral part. The pH of the soil. The pH of the soil or soil reaction indicates the acidity or alkalinity of soil. It is measured in pH units. It is defined as the negative logarithm of the hydrogen ion concentration. With the increase in the amount of hydrogen ions in the soil pH also increases, leading to being more acidic. Soil pH is considered to be a master variable in soils because of the control it has on the many chemical processes that take place. It specifically affects plant nutrients availability by controlling the chemical forms of the nutrient. The pH in the digestive system. Our stomach produces hydrochloric acid, which helps in the digestion of food without causing any harm to the stomach. When the stomach produces too much acid, it leads to indigestion and causes pain and irritation. The solution to this pain is the use of bases called antacids, which neutralize the excess acid. The pH change as the cause of tooth decay. The cause of tooth decay is the corrosion of the tooth enamel. This tooth enamel, made up of calcium phosphate, is the hardest substance in our body. It is not soluble in water but gets by acid and when the pH is below 5.5. The bacteria present in our mouth produce acids by degrading sugar and food particles that are left in the mouth after eating. To prevent this, clean the mouth after eating food. Also, using toothpastes, which are basic, neutralizes the excess acid and prevents tooth decay. Did you know? Animals and plants release acids in self-defense. For example, a bee sting or stings by a nettle plant. These are self-defense mechanisms developed by nature for plants and animals. Family of salts. Salts are formed from the reaction between acids and bases. It is produced when the H+ ion of the acid is replaced by a metal ion or by the ammonium ion. Salts with the same positive or negative radicals are said to belong to a family. For example, NaCl and Na2SO4 belong to the family of sodium salts. Similarly, NaCl and KCl belong to the family of chloride salts. pH of salts. Here is the pH of salts. A strong acid and a strong base pH value of 7. A strong acid and a weak base pH value less than 7. A strong base and a weak acid pH value more than 7. Chemicals from common salts. The following are some of the chemicals produced from salts. Common salt. Common salt with the chemical name of sodium chloride is an ionic compound with the formula NaCl. It is responsible for the salinity of the ocean. It is commonly used as a condiment and food preservative since it is the major ingredient in edible salt. Sodium hydroxide. Sodium hydroxide, commonly known as caustic soda, has a molecular formula as NaOH. It is a highly caustic metallic base available in pellets, flakes, granules, and as a 50% saturated solution. It is soluble in water, ethanol, and methanol. It is used as a strong chemical base in the manufacture of pulp and paper, textiles, drinking water, soaps and detergents, and as a drain cleaner. Bleaching powder. Bleaching powder, with the chemical name of calcium hypochlorite, is a chemical compound with formula CaClO2. It is used mainly for water treatment and as a bleaching agent. It is relatively stable chemical and has greater chlorine available than sodium hypochlorite. Baking soda. Sodium bicarbonate or sodium hydrogen carbonate, commonly known as baking soda, is the chemical compound with the formula of NaHCO3. It is a white solid that is crystalline but appears as a fine powder. It has a slightly salty alkaline taste. Washing soda. Sodium carbonate, commonly known as washing soda or soda ash, with the chemical formula of Na2CO3, is a sodium salt. It is domestically well known for its everyday use as a water softener. It can be extracted from the ashes of many plants. It is synthetically produced in large quantities from salt and limestone. Did you know? Water of crystallization is the water that occurs in crystals. It is necessary for the maintenance of crystalline properties but capable of being removed by sufficient heat. It is the total weight of water retained by certain salts at a given temperature. Summary. Let us summarize what we have learnt. An acid is a substance that produces hydrogen ions when added to water, whereas a base is a substance that produces hydroxide ions when added to water. Olfactory indicators indicate whether a particular substance is an acid or base due to change in their smell. Every liquid you see will probably have either acidic or basic traits. All metals above hydrogen in the reactivity series react with dilute acids to form their respective salt and free hydrogen. Acids react with carbonates and hydrogen carbonates to form their respective salt, water, and carbon dioxide. Acids and bases are the chemical opposites of each other. When acids are mixed in an aqueous solution, they produce ions. A pH scale is a scale for measuring hydrogen ion concentration in a solution. Salts are formed from the reaction between acids and bases.
Introduction. Do you all know that the organic food that we all eat contains carbon? Carbon? But teacher, isn't that bad as it contaminates our food? No, Ramesh, carbon has nothing to do with the pesticides or chemicals. In fact, it makes our food healthier. That is why carbon is a very important element in our day-to-day life. Children, in this lesson, you will learn about carbon, the versatile nature of carbon, the chemical properties of carbon, and a few important carbon compounds. Objectives. At the end of this lesson, you'll be able to identify the covalent bond in carbon, explain the versatile nature of carbon, describe the chemical properties of carbon compounds, describe important carbon components, bonding in carbon, the covalent bond. Carbon is the chemical element with symbol C and atomic number 6. As a member of group 14 on the periodic table, it is non-metallic with 4 electrons available to form covalent chemical bonds. A carbon-carbon bond is a covalent bond between 2 carbon atoms. The most common form is the single bond, a bond composed of 2 electrons, one from each of the 2 atoms. Carbon also has the unique characteristic to form long chains of its own atoms. This property is called catenation. The allotropes of carbon are graphite, diamond, and amorphous carbon. Versatile nature of carbon. Organic compounds are made up of carbon, hydrogen, oxygen, and a few other elements. The unique nature of the carbon atom and the arrangement of the bond carbon forms with other atoms enable formation of organic compounds. Tetravalency. Carbon is tetravalent in nature. It always forms covalent bonds by sharing electrons with 1, 2, 3, or 4 carbon atoms or atoms of other elements or groups of atoms. Strong carbon-carbon covalent bonds. Carbon atoms form a strong bond resulting in the formation of stable compounds. Carbon atoms can also form stable bonds with other atoms. Carbon-carbon multiple bonds. A carbon atom can also form multiple bonds as it is small in size. Double and triple bonds can also be formed with not only carbon, but with atoms of other elements like oxygen, nitrogen, and so on. These multiple bonds provide a variety in the carbon compounds. Saturated and unsaturated carbon compounds. Carbon forms many compounds. The two main types of compounds are saturated compounds and unsaturated compounds. Saturated compounds. The carbon and hydrogen compounds, where the adjacent carbon atoms contain only one single covalent bond, are known as saturated hydrocarbons. The reason for the formation of saturated hydrocarbons is because all the 4 bonds of carbon are fully utilized and no more hydrogen or other atoms can be attached to it. These are known as alkanes. Unsaturated compounds. Compounds of carbon and hydrogen that contain double or triple covalent bonds between the carbon atoms are called unsaturated hydrocarbons. These are formed as all the bonds of carbon are not fully utilized by hydrogen atoms, and more of these bonds can be attached to them. Double covalent bond unsaturated hydrocarbons are known as alkenes, and triple covalent bond unsaturated hydrocarbons are known as alkynes. Chains, branches, and rings. Many compounds contain carbon atoms and are linked with each other. The chains of carbon atoms are linear chains, branched chains, and cyclic rings. Linear chains. Tetravalency and catenation of carbon compounds allows the formation of stable chains of atoms with different chain lengths and structures. Branched chains. Carbon compounds can be branched when the carbon atoms are more than 3. Branched chains give rise to a different structure to the parent alkane. Cyclic rings. Carbon rings are rings of carbon atoms. The number of atoms to form a ring is 5 and 6 carbons. Rings of 3 and 4 are possible, however, they have a larger ring strain and are unstable. Carbon, a friend in disguise. Carbon is a friendly element. It not only bonds with hydrogen, but also with other elements such as halogens, oxygen, nitrogen, and sulfur. The compounds are formed in the same manner as with hydrogen. However, instead of hydrogen, the other elements is used, and this element replacing hydrogen is called a heteroatom. A functional group is created that confers specific properties to the compound without considering the length and nature of the carbon chain. Homologous series. Homologous series is a series of related chemical compounds that have the same functional group. These differ in formula by a fixed group of atoms. The successive members of such series are called homologous. Even though the general formula remains constant in a homologous series, specific members of the series may have different structures and properties. However, the reactivity usually remains the same. In any homologous series, a gradation in the physical properties is observed. This gradation occurs due to the increase in the melting points and boiling points along with increasing molecular mass of the compound. Nomenclature of carbon compounds. The system of assigning a proper name to a particular carbon compound is called nomenclature. Most carbon compounds have two types of names. Trivial names. Trivial names are the commonly used names of carbon compounds. These are derived mostly from the source of the compound. However, names formed using this manner is ambiguous and repeating. IUPAC names. Carbon compounds now need to be named in a more systematic way. A committee called the International Union for Pure and Applied Chemistry, IUPAC, put forward a system of giving scientific names to carbon-based compounds. These names followed all over the world and are called IUPAC names. Chemical properties of carbon compounds. Carbon is a very reactive element. Main chemical properties are listed. Combustion. The burning of a substance is called combustion. It is a process that generates a lot of heat. When carbon and its compounds are burnt, heat energy, carbon dioxide, and water are produced. Oxidation. Oxidation is a process where carbon compounds are easily oxidized after combustion. After complete oxidation, additionally, we have reactions in which carboxylic acids are generated through alcohol after combustion. Addition reaction. Hydrogen is added to unsaturated hydrocarbons in the presence of catalysts and produce saturated hydrocarbons. These catalysts are substances that cause a reaction to occur or proceed at a different rate without affecting the reaction itself. Substitution reaction. Most reagents are not able to generate any reaction from saturated hydrocarbons. Hence, these saturated hydrocarbons are inert. However, in sunlight, chlorine gets added to hydrocarbons. Since chlorine replaces the hydrogen atoms one by one, it is called a substitution. Ethanol and ethanoic acid. Ethanol. Ethanol is commonly known as alcohol and is liquid at room temperature. It is an active ingredient of all alcoholic drinks. It is a good solvent and hence is used in medicines. Consuming small quantities of dilute ethanol leads to drunkenness, but intake of a small quantity of pure ethanol can lead to death. Ethanoic acid. Ethanoic acid is commonly known as acetic acid. It is a part of the carboxylic acids group. When 5 to 8% solution of acetic acid is mixed in water, it forms a substance called vinegar. The melting point of pure ethanoic acid is 290 Kelvin. Because of this property, it freezes during winter and hence is also known as glacial acetic acid. Carboxylic acids are characterized by special acidity. However, as carboxylic acids are not ionized, they are weak acids. Soaps and detergents. Soaps and detergents are used in our daily life to wash clothes, clean hands, clean utensils, etc. The substances that form soap are sodium or potassium salts with long chains of carboxylic acids. The soap molecules form a separate structure called micelles. A micelle is formed when a variety of molecules, including soaps and detergents, are added to water. These molecules must have a strong polar head and a non-polar hydrocarbon chain tail. When you add this molecule to water, the non-polar tails of the molecules clump into the center of a ball. This is because they are hydrophobic or water-hating. The polar head of the molecule interacts with the water molecules on the outside of the micelle. Did you know? Artificially manufactured hydrocarbons are called Trans. Our body lacks the enzymes to properly break down the trans compounds. That is why trans fats are dangerous and unhealthy, as they tend to build up. Carbon is the fourth most abundant chemical element in the universe by mass after hydrogen, helium, and oxygen. Carbon is abundant in the sun, stars, comets, and in the atmospheres of most planets. Summary. Let us summarize what we have learned. Carbon is a non-metallic substance with 4 electrons and helps in forming covalent bonds. The versatile nature of carbon can be summarized with tetravalency, strong carbon-carbon covalent bonds, and carbon-carbon multiple bonds. The chains of carbon atoms are linear chains, branched chains, and cyclic rings. Carbon is a friendly element that bonds with other elements. Homologous series is a series of related chemical compounds that have the same functional group. The system of assigning a proper name to a particular carbon compound is called nomenclature. The chemical properties of carbon are combustion, oxidation, addition reaction, and substitution reaction. Introduction. Most of the substances around us undergo changes. Some of these changes can be temporary, with no new substances being formed. They are called physical changes. In certain other changes, new substances are formed and the parent substance loses its identity. In such changes, we cannot get back the original substance from the new substance by simple means. They are called permanent changes. For example, burning of paper to yield carbon. When paper is burnt, black particles of carbon ash is formed. Now it is not possible to get back paper from it. This is a permanent chemical change. Objectives. At the end of this lesson, you'll be able to recognize chemical changes, write equations to represent a chemical reaction, classify chemical reactions, list examples for different types of chemical reactions. Chemical reactions. A chemical reaction is that in which a substance or substances react chemically to form a new substance or substances. The substances that take part in a chemical reaction are called reactants. The new substances which are formed are called the products. Iron plus sulfur gives iron sulfide. Iron and sulfur are the reactants and iron sulfide is the product. When sugar is heated, it gets charred. The water molecules in the sugar leaves behind carbon. Writing a chemical equation. In a chemical reaction, the reactants, one or more, react together and form a new compound known as the product. For example, aluminium oxide reacts with dilute sulfuric acid to form aluminium sulfate and water. The reaction can be written as aluminium oxide plus dilute sulfuric acid gives aluminium sulfate and water. The following steps are followed to write a chemical equation. Symbols and formulae of reactants are written first on the left-hand side. If there is more than one reactant, then a plus sign is placed between the different reactants. Aluminium oxide and dilute sulfuric acid, for instance, are written as Al2O3 plus H2SO4. An arrow is marked after the reactants to indicate that they react to form the product. Symbols and formulae of the compounds formed, products, are written after the arrow on the right-hand side, which indicates that these are formed. Here also a plus sign is placed between the different compounds formed. For example, Al2O3 plus 3H2SO4 gives
Al2SO4 3 plus 3H2O. Balancing the equation. The chemical equations are based on the law of conservation of mass. According to this law, mass can neither be created nor be destroyed in a chemical reaction. This will be possible only if the total number of each type of atom is the same on the reactant side as well as on the product side of the equation. Equations in which the number of atoms of different elements in the reactants are the same as the number of atoms on the product side are known as balanced equations. Balancing the equation. Al2O3 plus H2SO4 gives Al2SO4 3 plus H2O, equation 1. The above equation is an unbalanced one. There is only one atom of sulfur in the reactant side, while there are 3 atoms of sulfur in the product side. Al2O3 plus 3H2SO4 gives Al2SO4 3 plus H2O, equation 2. Now there are 6 hydrogen atoms on the reactant side and only 2 hydrogen atoms in product side. Multiply H2O molecules in the above equation by 3. Now the equation 2 becomes Al2O3 plus 3H2SO4 gives Al2SO4 3 plus 3H2O, which is equation 3. Now in the equation 3, the oxygen atoms are 15 both in reactant and product side. So the final balanced equation is Al2O3 plus 3H2SO4 gives Al2SO4 3 plus 3H2O. Different types of chemical reactions. Elements and compounds interact with each other to produce a variety of substances. Millions of compounds have been formed by chemical reactions between elements or compounds. Chemical reactions require different sets of conditions such as temperature, pressure, presence of light, etc. Chemical reactions occur in a variety of systems. For example, in the human body, plants, industries, nature, etc. Types of chemical reactions. Combination reaction, decomposition reaction, displacement reactions, double displacement reactions, combination reactions. In some reactions, new matter is added to the original substance and the substance gains in mass. Such a reaction is called a combination or synthesis reaction. Combination reactions are those in which one element reacts with another to form a compound. Such reactions are also known as synthesis reactions. For example, hydrogen combines with oxygen to give water. 2H2 plus O2 gives 2H2O. 2Cu plus O2 gives 2CuO. 4Fe plus 3O2 gives 2Fe2O3, rust. Take a magnesium ribbon and heat it over a flame. It burns, giving out a bright white light. The magnesium ribbon becomes white powder. Now add some water to the powder and put a drop of red litmus. The red litmus turns blue. This is due to combination reaction. Oxygen in the air combines with magnesium to give white powder of magnesium oxide. Magnesium oxide reacts with water to give magnesium hydroxide. Being basic, it turns red litmus blue. Decomposition reactions. Decomposition reactions are those in which a compound breaks down into simpler compounds. For example, on heating, calcium carbonate decomposes to give calcium oxide and carbon dioxide. CaCO3 gives CaO plus CO2. Water decomposes to give hydrogen and oxygen when electricity is passed through it. Take a piece of a marble. Hold it with a pair of tongs. Heat it over flame for some time. Now let it cool. Drop the solid into water. Add a drop of red litmus to the solution. The color of litmus changes to blue. Calcium carbonate marble decomposes to calcium oxide and carbon dioxide. The calcium oxide formed reacts with water to give an alkaline solution. Therefore, red litmus turns blue. Take 0.5 gram of zinc carbonate in a test tube. Fit the test tube with a cork and a delivery tube. Heat over the flame. You will see a colorless gas is given out. The gas, on passing through lime water, turns it milky. Heating zinc carbonate decomposes it to carbon dioxide gas and zinc oxide. The carbon dioxide turns lime water milky. Heat about 1.0 gram of ferrous sulfate in a china dish. On strong heating, the green color of ferrous sulfate changes to brown. A pungent smelling gas also comes out of it. This is due to the decomposition of ferrous sulfate to give brown ferric oxide and pungent gases like SO2 and SO3. Displacement reactions. A displacement reaction is a reaction in which an atom or a group of atoms present in a molecule is displaced by another atom. For example, iron when added to a solution of copper sulfate displaces copper metal. Dissolve 0.5 gram of silver nitrate in 10 ml water in a test tube. Place a clean copper wire in the test tube. Keep it for some time. Shining crystals of silver appear on the copper wire. The color of the solution becomes bluish as some copper nitrate is formed. In this reaction, iron metal has displaced copper from the solution of copper sulfate. Take copper sulfate solution in a test tube. Place the iron nail in the copper sulfate solution and keep it for some time. After some time, the blue color of the solution fades and red-colored copper metal is displaced from the copper sulfate solution. The displacement reaction which occurs is Fe plus CuSO4 gives FeSO4 plus Cu. Some other examples of displacement reactions are 2Na plus 2H2O gives 2NaOH plus H2. 2Al plus Fe2O3 gives Al2O3 plus 2Fe. Double displacement reactions. Double displacement reactions are those in which two compounds exchange ions to form two new compounds. These reactions are also called partner exchange reactions. These reactions occur in ionic compounds. For example, in the reaction of copper sulfate and hydrogen sulfide, copper sulfite and sulfuric acid are formed. Thus, the partner of copper is exchanged for the partner of hydrogen in hydrogen sulfide. The reaction of barium chloride and sulfuric acid to form barium sulfate is also a double decomposition reaction. The neutralization reactions are also double decomposition reactions. Redox reaction. Redox reactions are those in which oxidation and reduction takes place at the same time. In these reactions, one substance is reduced while the other is oxidized. Activity. Take a china dish and add a small amount of copper powder and heat it. What happens to copper powder? The surface of copper powder has changed to black color. This is because oxygen has combined with copper and copper oxide is formed. If hydrogen gas is passed over this heated material, CuO, the black coating on the surface turns brown as the reverse takes place and again copper is obtained. Cupric oxide changes into copper. Oxygen is thus removed from cupric oxide. Since removal of oxygen is reduction, cupric oxide is reduced to copper. Hydrogen removes this oxygen from cupric oxide. Hence, hydrogen is the reducing agent. Thus, oxidation and reduction occur simultaneously. For example, sodium gets oxidized when it changes to Na+. Oxidation is defined as the gain of oxygen or loss of hydrogen or loss of electrons by a substance. Reduction is defined as the gain of hydrogen or loss of oxygen or gain of electrons by a substance. Zinc gets oxidized to Zn2+ when a zinc rod is dipped in a copper sulfate solution. In this reaction, zinc has lost 2 electrons to become Zn2+. Thus, zinc gets oxidized. On the other hand, Cu2+ gets reduced as it accepts 2 electrons released by Zn to become Cu. Corrosion. You might have noticed that old iron gates turn reddish-brown in color. The turning of iron materials into reddish-brown color is rusting of iron. Some other materials also tarnish the same way. The black coating on silver and the green coating on copper are other examples of corrosion. Corrosion is the process by which metals are eaten up gradually by the action of air, moisture, or a chemical on their surface. Rancidity. If a metal is reactive, its surface may be attacked slowly by the action of oxygen and water in the atmosphere. The metal reacts with the oxygen of air and water vapor of air, forming compounds on its surface. The formation of these compounds tarnishes the metal, that is, it makes the surface of the metal appear dull. The compounds formed on the surface of metal are usually porous and gradually fall off from the surface of metal, and then the metal underneath is attacked by air and water. The process goes on and on. In this way, the action of air and water gradually eats up the whole metal. When we keep food materials containing fat or oil for a long time, we get an unpleasant smell and the taste also changes. This is because the food materials get rancid. Rancidification is the decomposition of fats and oils by hydrolysis or by oxidation. Antioxidants are often added to fat-containing foods in order to retard the development of rancidity due to oxidation. Natural antioxidants include polyphenols, ascorbic acid, tocopherols. Synthetic antioxidants are butylated hydroxyanisole and butylated hydroxytoluene. Rancidification can be prevented to some extent by keeping food in refrigerators, by storing food away from sunlight and in airtight containers, by filling the nitrogen in packaging food materials. The nitrogen gas prevents the food material from being oxidized and thus prevent rancid. Did you know? A solution of slaked lime produced by the reaction is used for whitewashing walls. Calcium hydroxide reacts slowly with the carbon dioxide in air to form a thin layer of calcium carbonate on the walls. Calcium carbonate is formed after 2 to 3 days of whitewashing and gives a shiny finish to the walls. It is interesting to note that the chemical formula for marble is also CaCO3. Summary. Let us summarize what we have learned. Chemical reactions are permanent changes. Each chemical reaction can be represented by a balanced chemical equation. The different types of chemical reactions discussed are combination reactions, decomposition reactions, displacement reactions, double displacement reactions, redox reactions.
Introduction. As we already know that body of higher animals like man is formed of a number of organ systems. Yes, some of the examples are digestive system, respiratory system, circulatory system, excretory system, etc. So we can say that each system is specialized to do a specific function such as nutrition, digestion, respiration, transport of materials, excretion, respectively. In each system, all the organs work together so that whole of the system can work properly. Yes, in other words, we can say that all the organs of a system coordinate with each other so that the system can work properly. Coordination is the working together of the various organs in a systematic manner so as to produce a proper reaction to the stimulus. As we already know that something is called living when a movement is observed in it. This movement can be due to growth, as in plants, a seed germinates and grows. This movement in plants is stopped after a particular time. Yes, on the other hand, in animals and some plants, these movements are not connected with growth. Some examples of it are running of a dog, playing football of children, and chewing cud of cows. These movements are not related to growth. If we analyze these movements, we find a reason behind each and every movement. The dog may be running because it has seen a cat. Children play to have pleasure. Cows chew cud to help break up tough food so as to be able to digest it better.
Objectives. At the end of this lesson, you'll be able to understand coordination in animals and plants, find out what is stimulus, find out nervous coordination in lower animals, understand nervous coordination in higher animals, find out the unit of nervous system, neuron, find out types of neurons, find out types of nerve fibers, understand nervous system of man, understand structure and functions of central nervous system, human brain, find out structure and functions of spinal cord, understand structure and functions of peripheral nervous system, find out structure and functions of autonomic nervous system, understand reflex actions. Stimulus. While playing football, there is coordination between eyes for observation of ball, brain for analyzing these observation, and muscles for giving proper response and movement to the ball. Thus, we can say that every living organism respond and react to changes in the surroundings. The changes in the environment to which the organisms respond and react are called stimuli. Stimulus are of two types: external stimulus and internal stimulus. External stimulus is due to environmental factors like heat, light, sound, water, wind, etc. Internal stimulus occurs within the organism. It may be due to hormones, acids, enzymes, etc. present within the organism. Coordination in animals. In all the animals belonging to coelenterate to mammalia, multicellular control and coordination of body function is enabled by specialized cells called neurons. In higher metazoans, these neurons or nerve cells are organized to form a nervous system. In animals belonging to Arthropoda to mammalia, there is endocrine system also in addition to nervous system. The nervous and endocrine systems are collectively called neuroendocrine system. Nervous coordination in lower animals. In coelentrates, nervous system is of diffused type. Examples: hydra. In Platyhelminthes, ladder-type nervous system is present. Examples: tapeworm, liver fluke, etc. In annelids, a well-organized centralized nervous system is present.
This consists of a circumpharyngeal nerve ring and a nerve cord. In arthropoda, centralized nervous system like annelids is present, but their nerve ring is circumesophageal. Nervous coordination in higher animals. In higher organisms, 3 types of systems coordinate with one another to control and coordinate the body functions. They are receptor systems, nervous system, effector system. Receptor systems is formed of receptors or sense organs. These receptors are made up of highly specialized cells which receive stimuli and change them into appropriate nerve impulse, which are carried to CNS by nerve fibers of sensory nerves. Receptors are of 6 main types. Photoreceptors for light located in eyes. Phonoreceptors for sound located in internal ears. Olfactoreceptors for smell located in nasal chambers. Gustatoreceptors for taste located in taste buds on tongue. Tangoreceptors for touch located in skin. Thermoreceptors for changes in temperature located in skin. Nervous system analyzes the sensory nerve impulses and initiates the appropriate motor nerve impulses which are carried to appropriate effector organ by nerve fibers of motor nerves. Effector system is formed of effector organs which include muscles and glands and give the response. Example, contraction or relaxation of muscles and switch on or switch off of glandular secretion. Nervous system of man. The function of nervous system is to coordinate the activities of our body. It is the control system of all our actions, thinking, and behavior. The nervous system helps all other systems of our body to work together. The human nervous system receives information from the surroundings, processes it, interprets it, and then responds accordingly. The nervous system also passes information from one internal system to another. Example, as soon as we put food in our mouth, it immediately causes the release of saliva from the salivary gland. Human nervous system is composed of 3 parts: central nervous system, CNS, peripheral nervous system, PNS, autonomic nervous system, ANS. Neuron. The units which make up the nervous system are called nerve cells or neurons. Neuron is a functional and structural unit of nervous system. A neuron is a nerve cell with all its branches. Neuron is the longest cell in the human body and is about 100 centimeter long. A neuron is formed of 3 parts: cyton, dendrites, axon. Cyton. Cyton is a typical animal cell type structure which contains cytoplasm and a nucleus. It is spherical in shape and about 4 to 135 μm. It has a granular cytoplasm called neuroplasm which is enclosed by cell membrane called neurolemma. It also has a large spherical and centric nucleus with a nucleolus. It has all cell organelles like mitochondria, ER, Golgi bodies, lysosomes, ribosomes, etc. It has also a number of small-sized granules, Nissel's granules, which help in protein synthesis. Dendrites. Dendrites are small-sized branched fibers, many in number. They conduct stimuli to its cell body, hence called afferent in nature. Axon. Axon is actually the largest cell in the body. They are long-sized fibers. They are unbranched and only 1 in number. They conduct stimuli from cell body towards other neurons, hence it is called efferent in nature. They have 1 or 2 additional covering. Myelin sheath.
Schwann sheath. Myelin sheath around the axon is an insulating and protective sheath. At certain places, myelin sheath is absent, and that area is known as node of Ranvier. Schwann sheath covers whole of the axon. It also covers myelin sheath. Axon bears terminal and fibers which end into synaptic knobs. Types of neurons. On the basis of their functions, neurons are of three types: sensory, association, relaying, motor. Sensory neurons are found in sense organs. Association, relying neurons are found in brain and spinal cord. Motor neurons are also found in brain and spinal cord. Functions of neurons. Sensory neurons conduct nerve impulse from sense organs to the central nervous system, that is, brain and spinal cord. Relaying neuron is present in the CNS, receives these stimuli brought by sensory neurons, analyzes it, interprets it, and produces a message. Motor neurons conduct this message from CNS to the effectors. Central nervous system. Human brain consists of brain and spinal cord in animals. All life activities are under control of the brain. Human brain. Brain is a soft, whitish, large, and slightly flattened structure present in the cranial cavity of cranium. Weight of brain is about 1200 to 1400 grams. Human brain is covered with three meninges or membranes. Pie is inner meninges, arachnoid is middle meninges, and dura mater is outer meninges. The space between membranes is filled with cerebrospinal fluid. Brain has gray matter outside and white matter inside. Parts of brain. Human brain has three parts: forebrain, midbrain, hindbrain. Forebrain is anterior, 2/3 part of brain. It is main thinking part of brain. It has three parts. Olfactory lobe are one pair, small-sized, club-shaped. Cerebrum is the largest part of brain and forms about 80% of weight of brain. It has one pair of cerebral hemisphere. Each has four lobes: frontal lobe, parietal lobe, temporal lobe, and occipital lobe. Diencephalon is made of thalamus and hypothalamus. Midbrain is formed of two parts: optic lobes, cerebral peduncles. Hindbrain also has three parts: cerebellum, pons, medulla oblongata. Functions of different parts of human brain are as given in this table. Spinal cord. Spinal cord controls the reflex actions and conducts messages between different parts of the body and brain. Peripheral nervous system. Peripheral nervous system consists of nerves arising from the brain, cranial nerves, and nerves arising from the spinal cord, spinal nerves. It assists in transmitting information between central nervous system and the rest of the body. Autonomic nervous system. Autonomous nervous system. Parasympathetic and sympathetic system. Involuntary activities like breathing and beating of heart take place by the coordinated efforts of the medulla oblongata and autonomous nervous system. Reflex actions. When a receptor is stimulated, it sends a signal to the central nervous system where the brain coordinates the response. But sometimes a very quick response is needed, one that does not need the involvement of the brain. This is a reflex action. Reflex actions are rapid and happen without us thinking. Example, you would pull your hand away from a hot flame without thinking about it. The process is as follows. A receptor detects a stimulus. This is indicated by the red on the hand. A sensory neuron sends a signal to the relay neuron. Then relay neuron sends the signal to the motor neuron. Then motor neuron sends a signal to the effector. Then effector produces a response. As a result, the hand is pulled away quickly. Assessment. Before proceeding further, let us know how much have you learned. Drag and drop the correct option. Did you know? Brain is the highest coordination center in human body. Hypothalamus is commonly known as thermostat of the body. Meningitis is the inflammation of meningeal membranes. Cerebellum is also known as little brain. Summary. Let us summarize what we have learned. Control and coordination are the functions of the nervous system and hormones in human body. The responses of the nervous system can be classified as reflex action, voluntary action, or involuntary action. The nervous system uses electrical impulses to transmit messages. The nervous system gets information from our sense organs and acts through our muscles. Chemical coordination is seen both in plants and animals. Hormones produced in one part of an organism move to another part to achieve the desired effect. A feedback mechanism regulates the action of hormones.
Introduction. As we already know that plants do not have a nervous system and sense organs like eyes, ears, or nose like the animals have. Yes, but they can still sense things like light, gravity, chemicals, water, and touch by actions of hormones on them. So we can say that plants can sense the presence of stimuli and respond to them. We can also say that the hormones in plants coordinate their behavior by affecting the growth of a plant. Yes, and the effect on growth of the plant can result in the movement of a part of a plant like root or stem. The plants respond to various stimuli very slowly by growing.
Objectives. At the end of this lesson, you'll be able to understand coordination in plants, find out immediate response to stimulus, understand movement due to growth, find out hormones in plants, study photoperiodism and flowering, find out hormones in animals, and understand structure and functions of endocrine glands. Coordination in plants. Plants lack nervous and muscular system. Plants respond to stimuli by showing two types of movements, growth-independent and growth-dependent. Growth-independent movements are usually quicker than growth-dependent ones and involve the use of electrochemical signals by the plant. Example: drooping of leaves of a touch-me-not plant when it is touched. Immediate response to stimulus. The movement of plants in the direction of stimulus is known as tropism. Tropic movements are shown in response to environmental factors such as light, gravity, water, and chemicals. Growth-dependent movements or tropic movements are slow, occurring either towards or away from the stimulus. Phototropism is directional movement of a plant part in response to light. Example: shoots show positive phototropism. Plant roots are negatively phototropic, whereas plant shoots are positively phototropic. Geotropism is directional movement of a plant part in response to gravity. Example: roots show positive geotropism. Plant roots are positively geotropic, whereas plant shoots are usually negatively geotropic. Chemotropism is directional movement of a plant or plant part in response to chemicals. Example, growth of the pollen tube towards the ovule. Hydrotropism is movement of a part of a plant in response to water. Example, roots. Movement due to growth. When a tendril comes in contact with the support, then the part of the tendril away from the support grows more rapidly than the part of the tendril that is in contact with the object. Thus, the tendril circles around the object and appears to cling to it. Hormones in plants. Plant hormones or phytohormones are chemical substances produced naturally by plants. They are capable of being translocated and regulate one or more physiological processes when present in low concentrations. Plant hormones and their functions are as given in table. Photoperiodism and flowering. Flowering in a plant occurs at a particular time of the year and is controlled by factors like photoperiod and temperature. The response of plants to the relative lengths and alternations of light and dark periods with regard to initiation of flowering is called photoperiodism. It was discovered by Garner and Allard in 1920. On the basis of photoperiod, plants are of three types: short day plants, long day plants, day neutral plants. Short day plants require longer dark period for flowering. Example, tobacco, rice, dahlia. Long day plants require longer light period for flowering. Example, wheat, oat, radish, lettuce. Day neutral plants are not dependent on photoperiod for flowering. Example, tomato, sunflower. Assessment. Before proceeding further, let us know how much have you learned. Match the following. Hormones in animals. The term hormone was introduced by Bayliss and Starling. The hormones in animals are produced by the endocrine glands and are chemical substances that control and coordinate activities of living organisms and also their growth. Animal hormones do not bring about directional growth depending on environmental cues, but promote controlled growth in various areas to maintain the body design. Animal hormones and their functions and deficiency diseases are as given in table. Endocrine glands. There are a number of endocrine glands which differ from one another in their location, structure, as well as in the hormones secreted by them and their functions. Endocrine system is formed of a number of endocrine glands and control and coordinates the body functions through their specific chemical secretions called hormones. Did you know? Thyroid gland is the largest endocrine gland of the human body. Deficiency of thyroxine in infants causes cretinism, characterized by reduced physical, mental, and sexual growth. Deficiency of iodine in the diet causes goiter, which is characterized by swollen neck. Adrenaline is also called emergency hormone or triple F hormone. Pituitary gland is commonly known as master gland. Deficiency of growth hormone, GH, causes dwarfism, while its excess causes gigantism. Deficiency of insulin causes diabetes. Summary. Let us summarize what we have learned. Plants do not only respond to light, but show tropisms in response to other stimuli as well. Phytohormones are of different types: auxin, gibberellins, cytokinin, abscisic acid, and ethylene. Flowering and seed germination in plants are regulated by the duration of light. This is known as photoperiodism. Phototropism is the movement of the body parts of plants in relation to direction of light stimuli. Geotropism is the movement of the body parts of plants in relation to gravitational pull of the earth. Hydrotropism is the movement of the body parts of plants in the direction of water. Endocrine system is formed of endocrine or ductless glands whose secretions are called hormones. Thyroid gland secretes thyroxine hormone and its deficiency causes cretinism. Parathyroid secretes PTH, which regulates calcium-phosphorus balance inside the body. Adrenal glands secrete two hormones, corticoids and adrenaline. Hypothalamus secretes releasing hormones which regulate hormonal secretions from anterior lobe of pituitary. Pancreas also secretes two hormones, insulin and glucagon, which regulate glucose level in blood. Testes secrete testosterone and ovaries secrete estrogen and progesterone.
Introduction. Rita, I have placed immersion rod and bucket to heat water. Do not go near it.
I wanted to ask you about this. How can electricity heat water or cook food, such as in an electric cooker that you use to cook rice?
This is all because of heating effect of electricity. Let me explain you this. Children, in this lesson, you will learn about electric current, electric circuits and effects of electric current. Objectives. At the end of this lesson, you will be able to define electric current and circuit, identify the potential and potential difference, describe the circuit diagram, explain Ohm's law, identify the factors on which the resistance of a conductor depends, describe the resistance of a system of resistors, explain the heating effect of electric current and electric power. Electric current and circuit. All things around us are made up of atoms. Each has three particles, protons, neutrons and electrons. Electrons spin around the center of the atom and have a negative charge. Protons are in the center of atoms and have a positive charge. An electric current is created when electrons move through a conductor. There are two types of currents, direct current, DC. A current that flows in one direction is called a direct current or DC. For example, a battery produces a direct current. Alternating current or AC. A current that flows back and forth is called an alternating current or AC. The symbol of electric current is I. Electric potential and potential difference. Let us look at the concepts of electric potential and potential difference. Electric potential. Electric potential is a scalar quantity denoted by E or V. It is a point equal to the electric potential energy of a charged particle at the location divided by the charge of the particle. Electrical potential difference. Electrical potential difference determines the direction of the flow of charge. For example, consider a pipe connected to a container through a stop cork. The quantity of water in the pipe is less than the quantity in the container. However, the level of water is higher in the pipe than the level in the container. When the stop cork is opened, the water begins to flow from the pipe to the container till the levels of water in both the pipe and the container are equal. This determines that it is not the quantity of water but the level of water which decides the direction of flow of water. It is the potential difference that is responsible for the flow of water. Did you know? The I symbol was used by André Marie Ampère. The unit of electric current is named after him. when he formulated the eponymous Ampere's force law discovered in 1820. Circuit diagram. A schematic diagram is easy to represent an electric circuit. There are conventional symbols that you can use to represent most of the elements used in the circuit diagram. The symbols are shown. Ohm's law. Ohm's law deals with the relationship between voltage and current. It states that the current through a conductor between 2 points is directly proportional to the potential difference across the 2 points. Factors on which the resistance of a conductor depends. There are 3 external factors that influence the resistance in a conductor. They are thickness, length, temperature. There is a 4th factor that influences the resistance, and that is the conductivity of the material. This, however, is considered an internal factor rather than an external one. Thickness. The cross-section area of a conductor or thickness can be compared to the cross-section of a hallway. If the hall is wide, it allows a high current through it. In case of a narrow hall, it would be difficult for the current to get through. This is due to the cross-sectional area that restricts the high rate of flow. Length. The length of a conductor is similar to the length of the hallway. A shorter hallway allows movement at a higher rate than a longer one. Temperature. The temperature of a conductor does not have less effect on the resistance of the conductor. The higher the temperature, the higher is the resistance. For example, when you turn on a light bulb at the first instance, the wire is cold and has a low resistance. But as the wire heats up, it gives off light and increases the resistance. Did you know? When you double the length of a wire, you double the resistance of the wire. Whereas, when you double the cross-sectional area of a wire, you cut the resistance in half. Resistance of a system of resistors. A resistor is known as a passive two-terminal electrical component that represents the electrical resistance as a circuit element. The current passing through a resistor is directly proportional to the voltage across the resistor's terminals. Thus, resistance is the ratio of the voltage applied across a resistor's terminals to the intensity of current through the circuit.
Combination of resistors. Combination of resistors are of 2 types.
They are resistors in series and resistors in parallel. Resistors in series. Resistors that are connected in series, where the current flows through them, one after another, are known as resistors in series. Here, the current depends on the applied voltage, the number of components, and the nature of components in the circuit. Resistors in parallel. Resistors that are connected such that they branch out from a single point and join up again somewhere else in the circuit are known as resistors in parallel. Here the current through each component is the same as if it were the only component present. So the total current flowing through the battery is the sum of the currents flowing through each branch. Did you know? For resistors in series, the current is the same for each resistor, whereas the resistors in parallel, the voltage is the same for each one. Heating effect of electric current. The heating effect of electric current is widely used today. This effect is caused when electric current is passed through a conductor. This generates heat due to the resistance it offers to the current flow. The work done in overcoming this resistance produces heat. The heat produced by a heating element is directly proportional to the square of the electric current passing through the conductor, the resistance of the conductor, the time for which current passes through the conductor. It is defined as H is equal to I square root RT and is known as Joule's law. Practical applications of Joule's law. The heating effect of electric current can be applied to many appliances. These include electric immersion water heater, electric iron box. A good heating element has a high resistivity and a high melting point. For example, an electric fuse is an example of heating effect of electric current. The rating given as 3A of an electric fuse states that the maximum current it can sustain is 3 ampere. Electric power. Electric power is the rate at which electric charge is transferred by an electric circuit. This is commonly known as electric power. The following are the components associated with electric power. The International System of Units, SI, defines the unit of electric power is watt, W. It is known as the power consumed by a device that carries 1 A of current when used at a potential difference of 1 V. Watt is very small unit. In actual practice, a much larger unit called kilowatt is used. This unit is equal to 1000 watts. The unit of electric energy is watt hour, WH, as electrical energy is the product of power and time. The commercial unit of electric energy is kilowatt hour, kWh, commonly known as unit. Did you know? Electric current is also used in nature. Natural examples include lightning, the solar wind, and the sources of the polar auroras. Summary.